Hi, this is Ms. Machula. Welcome to Earth and Environmental Science video lecture number 2. Space part 2. We're going to talk about seasons and tides. Our standards for today are the North Carolina Standard Course of Study, which asks us to explain how Earth's rotation and revolution about the sun affect its shape and how it's related to seasons and tides. The National Science Standards challenge us to develop an understanding of the origin and evolution of our Earth system. And then, as always, our next generation science standards will be using mathematical or computational representations to predict the motion of orbiting objects in the solar system. All right, seasons and tides. Let's get started. All right. Seasons occur because of the tilt of the Earth's axis. As you see here, as the Earth revolves around the sun, the axis does not change. It's always tilted at about 23.5 degrees. In the summer, that Earth's axis points the northern hemisphere towards the sun. So we would be warm for a good portion of the time, warmer, and so we would be having summer. Alternatively, the southern hemisphere is pointed away from the sun and would be experiencing winter. All right, as we revolve around the sun, we move what comes after summer, autumn, or fall, and this is our autumnal equinox. Now you can see that the tilt is pointed kind of perpendicular to the sun. And so we get kind of an even heating as the Earth rotates around and around, and we will be having some seasonal fall or spring-like seasonal temperatures. These two are very similar. All right, so this would be the fall season. As it continues around 365 days, remember, and it ends up on the other end, opposite of the summer, now our axis is pointed away from the sun. So just as over here we're in the axis, this lower portion of the axis in the southern hemisphere, when it was pointed away from the sun, it was having winter. So here, when the northern axis is pointing away from the sun, we're having winter. So you can see we're not getting the direct sun's rays where we are. So we are experiencing winter. And when it's in that position, it is the winter solstice. All right, we have one more season to go. We're continuing our year-long trip around the sun until we are again parallel to the sun. And this would be our spring season. It's very similar to fall. We have milder temperatures, and so kind of even temperatures. And that's because we are parallel, and both hemispheres are getting equal effects from the sun. And then it would continue on around to finish off the year. All right, so that tilt of the Earth's axis is the key to seasons. When it's tilted towards the sun, you're having summer. When it's tilted away from the sun, you're having winter. Don't let that fool you. Okay, so let's talk about some movements down here. The moon's orbit around the sun. So if you'll recall, we learned two terms, aphelion and perihelion. And so aphelion was afar in the elliptical revolution around the sun, where it's very, very far, or it is afar from the sun. And then we had perihelion, where it was peri or very close to the sun. All right, so, well, this holds true for any two orbiting bodies. They have as you remember Kepler's law, they have elliptical orbits. So one of those bodies will always be at one point closer to the focus and one will be further away. So when the moon is closest to the Earth, it's like perihelion, it's perigee. When it is afar from the Earth, or the furthest point from the Earth, like aphelion, we have apogee, so 2 A's. All right. All right, let's recall our phases of the moon. Remember that the moon phases occur because of the moon's appearance. As it progresses around the Earth, it's the motion of the moon and the sunlight reflected. Now, sun doesn't change, does it? Sun's going to be always there. So wherever this moon is, you will either be able to see some reflected sun, or in the case of a new moon, you will not. So the sunlight is constant, and that's what this inner circle is. The sun is always hitting half of the Earth. It just depends on where the moon is, though, in its orbit around the Earth as to how much you can see. So if the moon comes between the Earth and the sun, you cannot see this face of it. We're over here on Earth. We can't see this face, and that's called a new moon, where there's no moon in the sky. As it moves in its monthly course around Earth, now we can see a little bit of that sunlight that's hitting it, and that's called a waxing crescent. As it moves a little further, now it's beside the Earth, we can see half of the sun is hitting it, right? And so that would be called the first quarter. One more movement, we can see a little bit more. That's called waxing gibbous. And then finally, we have where it is completely behind the Earth and the sun hits it full on, and we can see the full moon. Then as we move further through the month, we will start to take some of that sunlight away from our view. So here we have a waning gibbous. Now it's parallel. We can see half of it. That would be the last quarter. As it moves closer to its moving between the sun and the Earth, we can see a waning crescent. If you've ever seen the Karate Kid movie, Wax On, Wax Off, you can use that to try and remember this. For wax on, waxing means you're adding light to the moon. And then the other one is waning, which means it's removing it. All right, remember that the moon revolves around the Earth. It takes 1 month for this to occur. So you have a new moon, a full moon, 2 quarter moons, and then you have some gibbous moons and crescent moons, 2 of each. An interesting thing is that just as the Earth rotates, the moon rotates while it's revolving around the Earth. The interesting thing is that the moon rotates at a speed of 1 month. It also revolves at a speed of 1 month. So as it turns, its rotation is matching its revolution. So that's why we only see one face of the moon. And I'll demonstrate that in class. All right, just a short note about eclipses. When the Earth comes between the sun and the moon, the Earth blocks the sun's rays. So we get a new moon, or we get a moon that we cannot see. It's completely eclipsed. And that's more common than the other type. And then we have a solar eclipse. Now that's when the moon comes between the sun and the Earth. We had one last year. And as you can see, that this is only visible in a small area. And as the Earth turns during the day, that area moves across the globe. Up here, everyone on Earth can see the lunar eclipse. A solar eclipse can be viewed wherever that pinpoint is being blocked. All right, let's talk about the moon's role in Earth's tides. We're going to go into tides now. Tidal bulges, well, let's start with the Earth. The Earth has water on it, and because of that, it's fluid. When the moon comes close to the Earth, it has an effect of a gravitational pull. And so it creates this bulge through the equator of the Earth, or wherever the moon is actually. And so that tidal bulge is due to gravity. Now, interestingly enough, so we have the moon here, and you would say, okay, so it's pulling the water that way. Well, what's going on over here? Don't forget that the Earth is rotating, and so inertia causes the opposite side to be pulled out as well. It's kind of like a spinning top. Okay, so what are tides? We know that tides are the changes in the elevation of the ocean surface. Low tide, the water is further out to sea, and high tide, it comes up on the shore. They're primarily caused by the gravitational pull of the moon, but there's also a small amount of gravitational pull from the sun. Remember, the sun is much larger. It might be further away, but it's huge, it's massive. So it also exerts some gravitational pull on the ocean. But the moon is the main thing to watch. All right, remember that gravity or gravitational pull causes tides. All right, when the pull of the moon causes water to be pulled towards it, we're going to call that a tidal bulge. Because, and as we said, because the Earth is spinning, that tidal bulge is also found on the opposite side of the Earth from the moon. The difference in the height of sea level from low tide to high tide is what we call a tidal range. All right. So let's see if I can explain this. So when the sun, earth, and moon line up, and there could be two instances of this. You remember the moon is moving around the earth. It takes a month, and the sun stays where it is. And so when it's lined up in a line, or the moon could be on this side as well, right? This would be a new moon because the sun's light is not reflected on it, but a full moon would be on this side. It causes, not only does the sun have this yellow portion here is the sun's pull on the water or the oceans, and the orange section is the moon's pull. It is a double pull, so it's going to have a really high tide, and on these areas right here, it will have a very low tide. You can see there's no pulling of the water, so you're just really low and really high. When that happens twice a year, we call that a spring tide. Now there's two other positions of the moon as opposed to lined up straight in a line so that it's all the pull is linear. You could have the moon in the quarter phases, either up here or here, as in the illustration. So the sun still pulls its part of the water, right, this yellow portion, and the moon will pull this orange portion. So you can see a high tide and a low tide have very little difference between them. We call that a neap tide. And both of these occur, spring tides and neap tides, occur 2 times a month. So we have spring tide, neap tide, spring tide, neap tide, spring tide. And we'll demonstrate this in class. Here's another example of what I was just talking about, and the effects of, you can barely see it here, but solar and lunar gravitational pull. All right, I'm going to show you a quick animation. So you can see this now. So this yellow portion here is the sun's gravitational pull. And as the moon moves around, it pulls that water wherever it is. All right. So you see here we have a neap tide, spring tide, neap tide, spring tide. All right, that's it. This has been a Ringo and Ollie production. Have a great day.